Welcome to the Organic Chemistry Podcast, Dr. Brian Lloyd's Scribblecast of organic chemistry lectures and solutions to homework problems. In this homework problem, you were asked to indicate if p-Nitrophenol was more or less acidic than phenol. Using resonance structures, you had to explain your answer fully. You were given the following structure, and you were told that in order to draw the resonance structures, you would have to look at the Lewis structure of the NO2 fragment off the ring. In order to properly draw the structure for the NO2 group, you'd have to determine what that fragment is. Now, the total number of valence electrons of the NO2 fragment is, oxygen has 6, so that's 2 times 6 is 12. Nitrogen has 5, so that's 17 electrons. 1 electron is to the end of the aromatic ring. Nitrogen has 5 electrons. 1, 2, 3, 4, 5. Oxygen has 6. Oxygen has 6. Nitrogen binds to the carbon of the aromatic ring. Makes that bond. One of the oxygens will make a double bond to nitrogen. That gives 2, 4, 6, 8, 2, 4, 6, 8. So these 2 electrons will be dumped in a dative bond. This will make the NO2 group look something like this. Where the formal charge on oxygen is negative and the formal charge on nitrogen is positive, and that's attached to the aromatic ring. So having done this, I can now draw the NO2 when I need it as its proper Lewis structure form. So in order to evaluate the acidity of the p-Nitrophenol, I have to deprotonate it, react it with some base, and measure the stability, if you like, of the resultant anion. So I get NO2 here. There we go. Boy, that's a bad ring. Let's try that again. Okay. So here's my aromatic ring, and I've deprotonated. I have phenoxide. Now, we learned last time that phenol is more acidic than alcohols because it can resonance stabilize this negative charge around the ring. And so that's what I'll start doing. And we've stabilized it somewhat. So now I'll go down here. And I'll move this to this position. What I get is this. Now in this structure, I'm going to draw, it's a lone pair, the NO2 in its full form. And we'll come back to this structure in a moment. So I can continue drawing my structures. moving the lone pair around the ring. Okay. Now this is equivalent to the 5 resonance structures that we drew for phenol. Now remember, phenol is more acidic than an alcohol because of the delocalization of the negative charge. The ability to move the charge around the ring spreads the charge out, stabilizes it. The more resonance structures you delocalize the charge over, the more stable the charge is. Now I want you to focus in on this structure. I'm labeling it A. So far, all of the resonance structures we drew for p-Nitrophenol are exactly the same as the resonance structures you could have drawn for phenol. But the nitro group has one more resonance structure that it can give you. Instead of moving the electrons in this direction, the lone pair can move out towards the positive charge of nitrogen. If it does so, the pi electrons on the oxygen-nitrogen bond move out towards the oxygen. If you draw this, you get this. Minus on this oxygen, minus on this oxygen. Double bond to nitrogen. Nitrogen has still a positive charge. Double bond to this oxygen. Double bonds here and here. This structure, which I'm labeling B, is an extra resonance contributor. Now, because you have an extra resonance contributor, phenol could draw all of these resonance contributors. But because instead we don't have just 5 contributors, we have 6. And it's not just 6 contributors. The 6th contributor delocalizes the negative charge even further. Because there's more resonance contributors, the negative charge is spread out more. The anion that forms is more stable. If the anion's more stable, that means you will have a greater tendency to lose H+. This means that p-Nitrophenol is more acidic. Because it has more resonance structures, it delocalizes the negative charge, stabilizing the anion more, making it more able to form. P-Nitrophenol is more acidic. Now you might have guessed this just from resonance structure A. Even if you couldn't draw the resonance structures, you might have said, well, the negative charge next door to the very electronegative N and 2 oxygens is favorable. That would help stabilize that negative charge. Well, in fact, the electronegativity of the NO2 group also helps. So if you mentioned that, you would further substantiate your answer. So there you have it. P-Nitrophenol is more acidic because it delocalizes the negative charge over more resonance structures than phenol can. I'm Dr. Brian Lloyd. This is my Scribblecast. I thank you for listening. Thank you very much.